got something raised to a power. So this would be power rule the way it's written. I probably wouldn't want to change that. We could, but it's probably power rule. So let's just leave it as is. Grab my pencil here. All right, we got power rule, and let's just get on with it. All righty. Good grief. All right, power rule. All right, f prime of x is equal to, we're going to drop the 5 down in front, times everything inside, raised to the 4th power. Oh man, that should be a 1, not a 4. 1 raised to the 4th power. And now we have to take the derivative of this inside piece, which would be d dx of 2x minus 1 all over 2x plus 1. Well, what is the derivative of that? The derivative of this, we're now going to have to use quotient rule. So looking at this, we get 5 times all this stuff, 2x minus 1 all over 2x plus 1 raised to the 4th power. And now we're going to have a big quotient rule here. Quotient rule, we're looking at low d high minus high d low all over low squared. So the low is 2x plus 1 times the derivative of the top, which is 2, minus the top, 2x minus 1, times the derivative of the bottom, which is 2, all over 2x plus 1 squared. We can do some combining like terms in the numerator there. We get 2 times 2x, 2 times 1, that's 4x plus 2. And then we have this negative 2, so we can distribute this negative to the 2. So we have negative 2 times 2x, which is negative 4x, and negative 2 times negative 1, which is positive 2, all over 2x plus 1 to the 2nd power. And then we still have the 5 times 2x minus 1 all over 2x plus 1 raised to the 4th power times all of that. If we combine our like terms, I'm going to have to erase some stuff to do 13, but that's okay. If we combine our like terms here, we get 5 times 2x minus 1 over 2x plus 1 raised to the 4th power. The 4x and the 4x cancels. 2 plus 2 is 4. So we get 4 on top, and we get 2x plus 1 quantity squared on the bottom. If we look at this to the 4th power here, this really can be switched to have the numerator raised to the 4th power and the denominator raised to the 4th power. We can multiply the 5 and the 4 together. 5 times 4 is 20. So we get 20 in the numerator. We get 2x minus 1 to the 4th power in the numerator. And since we had 2x plus 1 to the 4th power and 2x plus 1 to the 2nd power, we have 6 factors of 2x plus 1 total. So we can write that as 2x plus 1 to the 6th power. That would be the same base and different exponents. So we would just add the 4 and the 2 to get the 6. And that's number 12. Number 13, the way number 13 is written is a quotient rule. Erase all this. Number 13 is a quotient rule to begin with, because we're starting with a quotient. So the directions ask us to what rule is the original problem written as, and it's written as a quotient rule. So let's hop right into the derivative. F prime of x equals, we're looking at low d high minus high d low all over low squared. So the low, what's the low is square root of x squared minus 1 times the derivative of the top, which would be 1, minus the top, which is x. And now we have to multiply by the derivative of the denominator, which is really this piece being raised to the 1/2 power. So we got to use chain rule to find the derivative of the bottom. So the 1/2 is going to go in front. We're going to multiply that by x squared minus 1. We're going to subtract 1, so we get negative 1/2. And we're going to multiply that by the derivative of x squared minus 1, which is 2x. And so we end up with the square root of x squared minus 1 minus this x over 2. The 2's are going to cancel out. We get x times x, which is negative x squared, divided by this x squared minus 1 to the negative 1/2. We can go ahead and move that to the denominator, and we can go ahead and write it as a square root. All right, so that would be our 1-star answer. If we were looking for just an adequate answer, that's pretty adequate. But if we want to make this look a little bit better, we need to find a common denominator here. So we put that over 1. We got two fractions we're trying to add together. The denominator on the right side, square root of x squared plus 1. So that's what I want this denominator on this side to be. So I'm going to multiply the denominator by the square root of x squared plus 1. But if I multiply the denominator by that, I also have to multiply the numerator by that. If we take a square root and multiply it by a square root of the same thing, the same expression, well, that square root just cancels out. So we just get x squared minus 1. And since we have the same denominator now, we can write this as 1 fraction. And then we have this negative x squared on top of the other fraction. And we can actually cross the x squareds out. And we get negative 1 over the square root of x squared minus 1. Number 14, looking at number 14, the way it's written, this is really this number raised to the 1/2 power. So that's power rule, the way it's written. We could do some rearranging depending on how you want to make this look. We could rearrange it, and then it would be quotient rule. It'd be probably more complicated doing that. So let's just leave it like it is and take the derivative. Using chain rule, imagine that like this is something raised to the 1/2 power. So the derivative is going to be that 1/2 raised to the negative 1/2. We're not going to change this on the inside. X times 4x minus 1. And then to take the chain rule in effect, we now have to take the derivative of this x over 4x minus 1, x over 4x minus 1, which would be quotient rule. So we're looking at low d high minus high d low all over low squared. So low is 4x minus 1. Derivative of x is 1 minus the top is x times the derivative of 4x minus 1 is just 4 all over 4x minus 1 squared. We can do some combining like terms. This 4x and negative 4x on top. This is going to be negative 4x, and this is going to be 4x minus 1. We can actually cancel the 4x and the negative 4x. So if we come back over here, we get 1/2. This is x to the negative 1/2 power, so we can write that as x to the negative 1/2 divided by 4x minus 1 raised to the negative 1/2. And then if we want to make both of those exponents positive, we can just switch both of them. So the 4x minus 1 to the 1/2 power actually goes to the top, and the x to the 1/2 can go to the bottom to make it positive. And we're going to multiply this by, it looks like, negative 1 over 4x minus 1 to the second power. We can multiply the 1/2 and the negative 1 together, and we get negative 1/2. We got some common factors here, one in the numerator, one in the denominator. So 4x minus 1 to the 1/2 and 4x minus 1 squared. We can simplify that. We have two factors in the denominator. We have half a factor in the numerator. So we can combine that. We end up with 1 over x to the 1/2. And then we have two factors in the denominator and a half in the numerator. So technically 1/2 minus 2 would be our exponent. That'd be minus 4 over 2, which would be negative 3 over 4 if we were to put it in the numerator. But we want to make it positive. So this 4x minus 1 is going to have a power of 3/4. And we can make that look a little bit nicer. We can put the negative 1 on top, and then on bottom we can put the 2. X to the 1/2, 2x to the 1/2, and then this 4x minus 1 to the 3/4 would be our final answer there. Number 15, look at number 15. The way it's written, it is a product rule. We can leave it like that. We can make that negative 3 a positive 3 to begin with, and it becomes quotient rule. It really doesn't matter to me how we do it. I might just leave it like it is because I like product rule, honestly. F prime G plus G prime F. All right, so let's just leave it like it is. See if we can take the derivative. All right, so derivative of f would be derivative of this x squared minus 4 to the negative 3 piece. So f prime of x would equal negative 3 times x squared minus 4. We're going to subtract 1 is negative 4, and we're going to multiply that by the derivative of the inside, which is 2x. And then we get x squared plus 4 to the third power. We're not changing that. Plus, now we're going to take the derivative of g, which is going to be chain rule again, 3 times x squared plus 4 raised to the second power times the derivative of the inside, x squared plus 4 would be 2x. But then we also have to multiply that by f, which is x squared minus 4 raised to the negative third power. Now we can multiply some things together. We can multiply the negative 3 and the 2x together. We can multiply the 3 and the 2x together. And then I'm going to just move some stuff to the denominator to make it positive. So we get negative 6x. If it has a positive exponent, x squared plus 4 to the third power, I'm going to leave it on top. And this x squared minus 4 to the fourth power to make it positive. Plus 3 times 2x is 6x. And we get x squared plus 4 squared. And we're going to move this x squared minus 4 to the negative 3 to the denominator. So we get x squared minus 4 to the third power. Now we could combine some like terms here, maybe. If we had any, we can do some factoring out. But since we do have two fractions, we probably do want to find a common denominator. So we're going to multiply this again by x squared minus 4. We're going to do that on top and bottom. And then we see that we have 4 factors of x squared minus 4 on the top and bottom. So we get negative 6x times x squared plus 4 to the third power plus 6x times x squared plus 4 to the second power times x squared minus 4 all over x squared minus 4 to the fourth power. Now technically we have 2 terms on top. They look kind of confusing, but we have this term and we have this term. We can factor some stuff out of that. Negative 6x and positive 6x. We can factor a 6x or a negative 6x out, whichever one you want. I'd probably factor a negative 6 out. It would just look a little bit nicer. So if we factor the negative 6x out, x squared plus 4 to the third power and x squared plus 4 to the second power, we have x squared plus 4 to the second power in common because they both at least have the second power. They both don't have the third power. So when we factor that out, what would be left over? Negative 6x divided by negative 6x is 1. And we would be left with 1 factor of x squared plus 4 because we had 3 and we factored 2 out. 6x, we factored negative 6x out. That's going to be a negative 1. And then we had 2 factors of x squared plus 4. We factored both of those out. But we do have this x squared minus 4 left over. So that's what the numerator would look like. The denominator would not change. X squared minus 4 raised to the fourth power. All right, at this point, we could probably combine some like terms. We can distribute this negative inside the parentheses, and we get negative x squared plus 4. The x squareds are going to cancel out. 4 plus 4 is 8. We can multiply the 8 and the negative 6 together. 8 times negative 6 is negative 48x times x squared plus 4 squared. And we took care of that whole parentheses on the far right there, the x squared plus 4 minus 1 times x squared minus 4. We took care of that. That equaled 8. And we multiplied the 8 and the negative 6 together. And then in the denominator, we have x squared minus 4 to the fourth power. So when we started talking about these different solutions, like this up here, way up here, this was our 1-star answer because that is the derivative. If we were asked to plug in a number for x, we could very easily do that from up there. If we just want to make it look really, really nice, we're looking at our 5-star answer down here at the bottom. You got 1 fraction, everything in the numerator is factored, everything in the denominator is factored. So that's what we would be looking for when we're talking about this 5-star answer. What would this 5-star answer look like? All right, I'm gonna get rid of that because I'm gonna be right there in just a second, but you can always rewind it and watch later. All righty. So sometimes they give you information instead of being in a table. It could be in function notation form, and then they just ask you to do some stuff. So they're asking us to find h prime of 2. So notation wise, can we find derivatives using chain rule and whatnot? So this is some expression being raised to the third power. So the derivative of that is going to be 3 times f of x raised to the second power. We're just using power rule there, combined with the chain rule, times f prime of x. And then we can find those things from the chart. We get h prime of 2 is equal to 3 times f of 2. If you look at the chart, f of 2 is -3 squared, and f prime of 2 is 6. We multiply all those things together, we get 9 times 3 times 6, which is 9 times, which is 27 times 6. And 27 times 6 is 162. So our final derivative, h prime of t, 162. Number 17, we got another derivative. Power rule here, 2 times whatever the inside is. We're never changing the inside when we're doing chain rule. Raised to the first power, we subtracted 1. And then we're going to multiply this by the derivative of the inside, which would be f prime of x minus g prime of x. And we definitely would need that inside parentheses. So then we're going to look these things up on the chart. We get 2 times f of 2 for h prime of 2. F of 2 is -3 minus g of 2 is +3 times f prime of 2 is 6 minus g prime of 2 is -2. 6 minus -2 is really 6 plus 2. So really we get 2 times -6 times negative, or +8 rather. 2 times -6 is -12. -12 times 8 is -96. I hope. I didn't check that one in my calculator. If it's wrong, then just check it in your calculator. That'd be okay. All right, this is really all of this raised to the 1/2 power. So again, we are looking at a power rule again. We have something raised to the 1/2 power. So the derivative is going to be 1/2 times whatever that something is. We don't change that. Raised to the -1/2 power. Now I'm probably going to run out of room, so I'm going to write it right below. We're going to multiply by the derivative of the inside, and the derivative of 4g of x is 4g prime of x, and the derivative of -x is -1, and the derivative of -1 is 0. So then we do h prime of 2 would be 1/2 times 4. G of 2 is 3, and I'm getting that from the table up top. It's not really a table, but the function notation there. -2 minus 1 raised to the -1/2 power. I probably should have went ahead and moved that to the denominator, but it's a little too late now. I will do that in the next step. G prime of 2 is -2, so we get 4 times -2 minus 1. So we end up with 1/2. We're going to go ahead and move this to the denominator. We get the square root of 4 times 3, -1/2, move to the denominator, be square root. 4 times 3 is 12. 12 minus 2 is 10. 10 minus 1 is 9. So we get 1/2 root 9 times 4 times -2 is -8 minus 1 is -9. So we get -9/2 times the square root of 9 is 3. So we get -9/6. We can divide both of those by 3. So we get -3/2 will be our final answer for number 18. Numbers 19, 20, and 21 are just classic chain rule problems. H prime of x, we have a composition of function and inside function. So we're going to take the derivative of the outside function. We're going to leave the inside function alone. And then we're going to multiply by the derivative of that inside function. So in this case, we got h prime of 2 would be equal to f prime of g of 2 times g prime of x. We would do the g of 2 first. G of 2 is 3. So we end up with f prime of 3 times g prime of 2. G prime of 2 is negative 2. And now we can look up f prime of 3 from up here. F prime of 3 is 4. So we get 4 times negative 2, which is negative 8. Another problem, we just switched the g and the h. H prime of x is equal to g prime times f of x. We're not going to change the inside function. And then we're going to multiply by the derivative of the inside function. I'm assuming you can probably look this up on the chart to find h prime of 2. So I'm not going to do that. This problem, very similar. We just have f of negative x. Yes, we can compose functions with itself. And we can compose functions with the reciprocal of itself. But this negative f of x is the inside function. So we're going to leave it alone. And then we're going to multiply by the derivative of that inside function, which would just be negative f prime of x. And at this point, finding h prime of 2 would just be computational. So again, I'm going to skip that to save you some time. So now we finished chapter 9. You should be able to do all the homework at this point. If you need any extra help, Khan Academy is there. Hopefully we've had time to go over that in class together and make sure you were set up on that so you can get on there and do that. By the end of the week, you'll have a quiz over chapter 9. The only content on there will be chapter 9. But as you can see, like chapter 8's on there too, because well, you can't forget quotient rule or power rule or product rule in order to do the chain rule. If you have any questions, please send me some messages or remind, and I'll get back to you as soon as I can.